This is a walkthrough of my GCSE predicted paper 2 for summer 2025. So that's the higher paper 2. Just to kind of reinforce that this is just intended to give students a challenging calculator paper 2 in a similar style to the Edexcel format. And I've not had any prior access to the Edexcel paper, so any similarity to that paper is purely coincidental. I just want to find the midpoint. So I'm going to find the average of the x coordinates, comma, the average of the y coordinates. So 3 plus 8 is 11, divided by 2 is 5.5. And 7 plus 13 is 20, divided by 2 is 10. So those are the coordinates of M. So we have a substitution here. We're just substituting in x equals minus 1.2. So this is what I'm going to put into my calculator. Always substituting for x using brackets. And just type this into my calculator. And I get the answer. I need to make sure that I write down all the figures in the calculator display. Right, question 3. P is 20% larger than Q and Q is 20% smaller than R. Determine a formula linking P and R. So 27% larger than Q. I'm just going to write it as an equation as it said. So P equals 1.27 times Q. But Q is 20% smaller than R. So Q equals 0.73 times R. So I just need to link them together. So I'm just going to substitute this value of Q, which is 0.73R, into here. So 0.73R is just going to go into there. So P equals 1.27 times 0.73R, which equals 1.27 times 0.73. So P equals 0.9271R. And that's the relationship there. Right, so we have a scatter graph here. It shows the average hours of sunshine for 10 days. So that's our x-axis. And the number of units of electricity used to light a house, and that's our y-axis. Describe the relationship between the average hours of sunshine and the number of units of electricity used for lighting. So here, relationship, it's only one mark, so this is negative correlation. Estimate the number of hours of sunshine on a day when 7 units of electricity are used. So what we need here is the line of best fit. So I'm going to try to balance it now. So I've got 5 points on either side. Okay, and 7 units. So it's just under 10. Where that is intersecting is just looks like it's just below, so 9.8. With these, we've got to be careful. So I can see here that I've got 5 squares for each hour. So each square represents 12 minutes. So we could turn this into hours and minutes. However, sometimes you might get 6 squares. So each square represents 10 minutes, and sometimes you might get 4 squares where each square represents 15 minutes. So a question might also ask you for hours and minutes, so just be careful of that. Here we're fine, it's just saying a number of hours, so this is totally fine. So question 5, a number p is rounded to 1 decimal place. The result is 45.6. Complete the error interval for p. So 1 decimal place means that we are 1 decimal place is the nearest 0.1. So divided by 2 is 0.05. So we've got that above. So 45.65 and 45.55 when we subtract that off. Right, question 6. AD is x centimeters, so I'm going to write this on the actual diagram. AD being x. BC is 10 centimeters longer than AD. So BC is 10 centimeters longer than x. AB is 1 centimeter longer than AD, which is x. So x plus 1. And then DC, that's the base, is 4 centimeters more than double AB. So AB is, I'm going to need to double that, so that is 2x plus 2. And 4 centimeters more than that, so that's 2x plus 6. So the perimeter of the trapezium is 92 centimeters. So adding all of these together, we've got 2x, 3x, 4x, 5x, then 6, 17. So 5x plus 17 equals 92. Rearranging this, we get 5x equals 92 minus 17 is 75. Then divide by 5, we get x equals 15. Now, that's not the end of the question because we're being asked to calculate the area of the trapezium. So I'm going to draw a little diagram of the trapezium. X is 15. This is 16. So the two parallel sides, 16. This is 2x plus 6. So double x is 30 plus 6 is 36. We don't need to know the slant height. So the area equals half the sum of the parallel sides. So that's 16 plus 36 times the distance between them, which is 15. Put that into the calculator. So 16 plus 36 divided by 2 times by 15 is 390 centimeters squared. So cumulative frequency table gives information about the ages of 100 people working in a factory, and we need to calculate an estimate for the mean age of the workers. So for mean, we need not the cumulative frequency table, we need the frequency table. So we need to recreate the frequency table from this one. So this is frequency. So obviously 20 to 30 just going to use these. 20 to 30 is 15. So the midpoint, actually I might as well just put in the midpoint. So I'll just erase that. So the midpoint of 20 to 30 is 25. Then this would be 30 to 40, so the midpoint would be 35. The running total is 43, so 43 minus 15, which is 28. So that would be the frequency. Then the next one will be 40 to 50, so 45. 77 minus 43 is 34. Then 55. 91 minus 77 is 14. And then the last one would be 65. And then that's 100 minus 91, which is 9. So that's our frequency table. So an estimate for the mean is going to then be the frequency times the midpoint, add them all together, and then divide by the total frequency, which is 100. So we're going to do 25 times 15 plus 35 times 28 plus 45 times 34 plus 55 times 14 plus 65 times 9. So we're going to get the total age of all of the workers. That's the estimated age, obviously, because we're using the midpoint. That is 4,240. And then the estimated mean is that age, total age, divided by the total number of workers, which is the total frequency, which is 42.4. Does that make sense? The highest frequency is peaking at the 40 to 50 mark. So, and then the next highest is in the 30 to 40. So that does make sense. So I'm quite happy with that. Right, so question 8. Saul carries out a survey about the number of nights guests stayed at a hotel. He asks at random 80 customers how many nights they stayed last month, and the table shows Saul's results. So we've got the number of nights, 1, 2, 3, 4, 5, 6, and more than 6, and the frequency for those nights. One of the 80 customers is chosen at random. What's the probability that this customer stayed for less than 4 nights? So less than 4 nights means we've got 1, 2, or 3 nights. So less than 4 is 1, 2, or 3. So we need to add together those frequencies. 13 plus 14 plus 18. So we'll write that down. 13 plus 14 plus 18 equals 45. So the probability that this customer stayed for less than 4 nights is 45 out of 80. But we want to simplify this, and that becomes 9/16. Last month, the hotel had a total of 1,800 guests. So this is more information, and this is another question. Work out an estimate for the number of customers who stayed at the hotel for 3 nights. So exactly 3 nights. So that is 18. So this is 18 out of 80. That's the actual probability. And then we multiply that by 1,800 guests. So 18 out of 80 times by 1,800 gives me 405. Question 9, indices. So we've got to simplify q squared all raised to the power 5. This is the power of a power rule. So we multiply the indices together. So that is q to the power 10. Then we need to simplify 2p to the power 5 all over 3, all raised to the power minus 2. So I'm going to deal with this in 2 stages. First of all, I'm going to deal with the reciprocal, so that's the negative power. So I'm just going to deal with the reciprocal, so it becomes 3 over 2p to the power 5 all squared. So I've dealt with that negative power. And then I just need to square everything here. So this becomes 9 over 4p to the power 10. And then the last one, we have to work out the value of n. 8 to the power 5 times 16 to the power n equals 2 to the power 8. Here the trick is to get everything in terms of base 2. So the base here is 8, the base here is 16, and the base here is 2. Everything needs to be in base 2. So this equation can be rewritten as 8, which is 2 cubed to the power 5, times 16, which is 2 to the power 4, to the power n, which equals 2 to the power 8. Then, using the power law, this becomes 2 to the power 15 times 2 to the power 4n, which equals 2 to the power 8. Using the addition law here, because I'm multiplying and the base is the same, I can use 2 to the power 4n plus 15 equals 2 to the power 8. Now I've got just 2 is the base, and I've got powers that are equal to each other. They must be equal to each other because 2 is the same base. Right, so that means that 4n plus 15 equals 8. That means, so subtracting 15 from both sides, 4n equals minus 7. Dividing by 4, I get n equals minus 7 over 4. Question 10. Show that 2x squared minus 3x minus 5 all divided by 4x squared minus 3x minus 7 can be written in the form ax plus b all over cx plus d, where a, b, c and d are integers. So the key here for algebraic fractions is to factorize both numerator and denominator. So for the numerator, I'm going to use the AC method. AC equals 2 times minus 5, which is minus 10. So I now want the factors of minus 10 that add to make minus 3. So that would be, minus 3, so minus 5 and 2. So 2x squared minus 2x, so plus 2x minus 5x minus 5. That's my numerator. And that can simplify. I can factorize each half separately. So that gives me 2x minus 5 and x plus 1. Then we go for the denominator. Same thing. AC equals 4 times minus 7, which is minus 28. Again, here we're lucky. It's again minus 7 and 4, so exactly the same things. So we get 4x squared plus 4x minus 7x minus 7, 4x x plus 1 minus 7 x plus 1, which gives us 4x minus 7 over x plus 1. So if we now bring the numerator and denominator back together again, we get 2x minus 5 times x plus 1 all over 4x minus 7 x plus 1. These can cancel, and we get 2x minus 5 over 4x minus 7. Don't be tempted to cancel any x's or things like that. This is as far as we can go. And this is the final answer. Question 11, we're going to use algebra to solve the following simultaneous equations. You must show all of your working. So first of all, I'm going to label them. So equation 1 and equation 2. I'm going to multiply, I think I'm going to make the y's the same. So I'm going to multiply equation 1 by 10 and equation 2 by 4. Right, so then we get 70x minus 40y equals 110. 16x plus 40y equals now 4 times 37 is 148. The y coefficient is the same magnitude, they're both 40, but one's negative, one's positive, so I'm going to add the two to eliminate. 70x plus 16x is 86x. The y's will cancel. I'm then going to get 148 plus 110, which is going to give me 258. Dividing by 86, I'm going to get the answer x equals 3. And substituting back in, I'm going to go for substituting into sub x equals 3 into equation 2. That's going to give me 4 times 3. I'm showing the substitution. It's very important to show this in brackets. Plus 10y equals 37. That's 12 plus 10y equals 37. Subtracting 12 from both sides. 10y equals 25. And divided by 10, I get y equals 2.5. Final solution. Question 12. So we've got the first 4 terms of a sequence. So let's check to see if there's any kind of, this could be arithmetic. So minus 1/7 minus fifth. So that's 51 over 35 that I'm adding. If I add that on to minus 1/7, I don't get 14/9. So it's not arithmetic. Am I multiplying by the same thing each time? No, because we'd be flicking between positives and negatives if we had a negative, or we'd always stay negative. So it can't be multiplying by the same thing each time. It's not Fibonacci. So almost certainly we're going to have a different nth term for my numerator than my denominator. So what I'm going to do is I'm going to investigate the numerator first of all. Minus 8 minus 1, 14, 37, and then the denominator. Well, the denominator 5, 7, 9, 11 looks like it's going up in twos, so that actually looks like it's quite straightforward. Looks like a nice arithmetic sequence. Minus 8 to 1, to minus 1 is plus 7. Minus 1 to 14 is plus 15. 14 to 37 is plus 23. So this is now the second difference. This looks like a constant second difference of plus 8. So we have a quadratic sequence here. So 2a equals 8, and that means a equals 4. So that means we have something that's based on 4n squared. That's my quadratic. So I'm going to write out the original. Minus 8 minus 1, 14, 37. And I'm going to take away 4n squared. That's my quadratic element. When n is 1, 4n squared is 4. When n is 2, then n squared is 4 times 4 is 16. N is 3 is 9. 9 times 4 is 36. And then n is 4. 16 times 4 is 64. And I'm going to take away the quadratic from the original. Is this my original? So minus 8 minus 4 is minus 12. Minus 1 minus 16 is minus 17. 14 minus 36 is minus 22. And 37 minus 64 is minus 27. So now we're looking at this, and this is always going down in fives. So minus 5, minus 5, minus 5. So this is based on minus 5n. And I find the 0 term, so I add 5. So minus 12 add 5 is minus 7. So this sequence is 4n squared minus 5n minus 7. So that's the numerator. The denominator, that's going 5, 7, 9, 11. So this is going up in twos. So this is just based on 2n. Take away 2 to get plus 3. So that is 2n plus 3. So my overall nth term is 4n squared minus 5n minus 7 all over 2n plus 3. Let's just double check that. If I substitute in n equals 1, I get 4 minus 5 minus 7, which is minus 8, and then 2 plus 3, which is 5. So I get minus 8/5, which works. So at least it works for the first one, so I'm quite confident with that one. And question 13. So the histogram gives information about the ages of people living in a village. You need to be careful with histograms, so we need frequency density. So I can see here we've got frequency density. Ages of people, so this is the age on the x-axis. The histogram is incomplete, so it's its area on the right-hand side that's incomplete. The total population of the village is 414. That's the total population. 48 people are between 30 and 40 years old. So one of the problems with this histogram is I can see that there's no scale on the frequency density axis. So I need to identify this scale by using the information that's given to me in the question. So 48 people are between 30 and 40 years old. So that means the area of this bar here is 48. That means we can use this to get some kind of scaling. So the class width is 10, so 48 divided by 10. So obviously frequency density equals frequency over class width. So in this case, it's a frequency of 48 over 10, which equals 4.8. So I can tell that this bar is at 4.8 here. That's 4.8, which means that this must be 5. Okay, I can see that's 0.2. Let's have a check. 1, 2, 3, 4, 5. Yeah, so 1, 2, 3, 4, 5, 6, 7. Right. 108 people are between 50 and 70. So 50 to 70 is 108 people. So 108, 108 is the frequency divided by the class width, which is 20. 108 divided by 20, which is 5.4. So 5.4, that's 5.4. Right, so that's out there to 70. And then where's the ruler? Right. So that's the 108 people there. Then the oldest person is 100. So what we need to do now is calculate how many people are between the 70 and 100 age group. And we'll use the total population for this information. So we need to calculate now 3.2 times 20. So we calculate this. 3.2 times 20. 3.2 equals 3.2 times 20 equals 64. So that's 64 there. Then 4.4 times 10 is 4.4 times 10 is 44. Then 7.2 times 10 is 72. I'm going to get the total of all of these people. 108 were between here. That's 108. Add all of these up. So 108 plus 72 plus 48 plus 44 plus 64 is 336. 414 minus 336 is 78. So it's 78 in the last, and the class width is 30, so divide by 30. So that is 2.6. 246. Just draw this freehand, just for speed. So that is the last 78. So that's the histogram completed. And we need to estimate the modal age. So this is doesn't come up very frequently. So let's have a look how to do this. What we need to do is we need to go to the highest frequency density, so the class width, that's the class that's got the highest frequency density, and we join the top left corner to the top left of the next class, and then we join the top right to the top right of the previous one. And then in that midpoint, that is where we do that. So I'm going to estimate that at 45. Question 14. So cylinders A and B are mathematically similar. The volume of cylinder A is 136 centimeters cubed. Volume of cylinder B is 459 centimeters cubed. The surface area of cylinder A is 210 centimeters squared. What's the surface area of cylinder B? So for this, we need to work out what first of all, the volume scale factor is. So 459 over 136. That's the volume scale factor. 459 divided by 136, which is 27 over 8. We can cube root that to get the length scale factor. So cube rooting that, we get, as cube rooting, we get 3 over 2. And then to get the area scale factor, we need to square that. That gives us 9 over 4. So the area scale factor is 9 over 4. We need to multiply that by the surface area of cylinder A. So times 9 over 4. So 9 over 4 times 210 gives us 472.5 centimeters squared. Question 15, a vectors problem. So, OPQ is a triangle, so I can see that that's the larger triangle. M is the midpoint of OP, N is the midpoint of PQ, so I can identify M and N. OP, so that's the side, is the vector A. OQ is the vector B. And we need to find ON in terms of A and B. So first of all, we need to find out what PQ is, because my route to from O to N is going to be, I'm going to write that down, O to N equals O to P plus P to N. I know what O to P is, but I don't know what Pn is. So first of all, I'm going to work out what PQ is, and I'm going to halve that because Pn is half of PQ. So PQ equals minus A plus B. So that means Pn equals minus a half A plus a half B. So that means ON equals OP, which is A, plus PN, which is a half B minus a half A. Simplifying this, we get A minus a half A is a half A. Half A plus a half B. Right, so that's the vector ON. Now we want to show that MN, so that's ON, show that MN is parallel to OQ. So M to N, the vector M to N, I'm going to use M to P plus P to N. M to P is a half of A plus Pn. Now Pn is a half B minus a half A. Well, a half A minus a half A is 0, and so it just leaves us with a half B. Now Mn is just equal to half B. Now OQ is 2 times Mn. That's double, because it's B and Mn is half B. That means, therefore, they are parallel. Therefore, Mn is parallel to OQ. Right. Question 16. There are 36 counters in a box. There are n red counters, the rest are green. 2 counters are selected at random without replacement. Very important, it's without replacement. So we've got 36 counters, n red and green. So we've only got red and green. 2 counters selected at random. So the probability of picking 2 red counters in a row is 4 over 21. Okay, so that is red and red. So the probability of red equals 4 over 21. Show that n squared minus n minus 240 equals 0. So this has obviously got to do with the probability. So let's look at what the probability might be. So the probability of R, of picking R, a red counter, is going to be n out of 36. That's the first one. If we're not going to replace it, then we're going to have n minus 1 over 35, because we're going to have one fewer counter. So that's going to be the probability of picking 2 red counters. So this must equal 4 over 21. So if I multiply the whole thing, so 36 times 35 is 1260. So this is n squared minus n over 1260 equals 4 over 21. So if I just multiply by the whole equation by 1260, 4 over 21 times 1260 is 240. I get n squared minus n equals 240, and we can see I'm almost there. I've got n squared minus n over here, and I've got 240 on the other side, so I've just got to take that away. I get n squared minus n minus 240 equals 0, as required. Right, so we have done that, show that. Then we need to calculate the probability of picking 2 green counters. So for this, we need to work out how many we have. So let's solve that equation. Now we could put this into the quadratic formula, or we could try to factorize this. Let's have a think if we can factorize this. What goes into 240? They're going to be very, very close to each other. 240, 16. Right, so 16 and 15 go into minus 240, so it'll be minus 6, n minus 16 and n plus 15. So just double check that. 16 times 15 is 240. Minus 16 plus 15 is minus 1. So n equals 16, or n equals minus 15. N must be greater than 0, must be a positive number. Therefore, n equals 16. So we have 16 red counters. The rest are green, so 36 minus 16 equals 20. So we've got 20 green counters. So we want to find the probability of picking 2 green counters in a row. So that's 20 over 36 times 19 over 35. That's the probability of green, 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 green. So 20 over 36 times by 19 over 35 is 19 over 63. Right. Question 17. So in the triangle ABC below, AC is 12.5 centimeters to 1 decimal place, and BC is 8.4 centimeters to 1 decimal place. The angle ACB is equal to X. I can see that ACB. Find the lower bound of X. So this is the lower bound of the angle. Okay, so I have the hypotenuse here, and I have the adjacent. So this is what's relative to X. So, and just for completeness, this is the opposite. If I'm dealing with the adjacent and the hypotenuse, if I write out SOHCAHTOA, I want the adjacent and the hypotenuse, so I'm dealing with cosine. I want to find the cosine of x, so I need the adjacent over the hypotenuse. So cos of x equals adjacent over hypotenuse. Now, from the shape of the cosine graph, that's the shape of cosine, cos x up to 360. Now, obviously, we're only going to be looking at up to 90 degrees. But notice here, if I want the smallest angle that I can possibly get, so i.e. closest to 0, then I'm going to need the highest possible cosine. So as the angle reduces from 90 degrees, the cosine increases. So to get the smaller angle, I need the higher cosine. So even though I want the lower bound of x, I need to get the upper bound of cosine of x. So we want the upper bound of cos x. If we want the upper bound of cos x, that means we want the upper bound of the adjacent, and we want to divide it by the lower bound of the hypotenuse. So cos x equals the upper bound of the adjacent, which is 8.45. Let's put the upper bound in 8.45 and the lower bound, which is 8.35, and the upper bound of the hypotenuse, which is 12.55, and the lower bound, which is 12.45. So we want the lower bound of the hypotenuse, which is 12.45, and then we want to do the inverse cosine of that. So x equals the inverse cosine of 8.45 over 12.45. Always check your angled units are in degrees. So inverse cosine of 8.45 over 12.45, which equals 47.25670093 degrees. Which equals 47.25670093 degrees. That's my lower bound. Question 18. Right, so we've got a circle, centre A, drawn inside a triangle. The sides BC, BD and CD are all tangents to the circle. So as soon as I hear this, tangents to the circle, I'm thinking to myself, the angle between a tangent and a radius is 90 degrees. So I'm already thinking about circle theorems, but let's have a think about that. Let's just keep that at the back of our minds. BD is 10 centimeters, CD is 8 centimeters. It's not been drawn to scale. So the area of the triangle is 24 square centimeters. Calculate the area of the circle in terms of pi. So we want the area of the circle. Obviously, for this, we need to work out what the radius is, which brings me back to using the circle theorem. So I'm now going to draw in the radii. Okay, I'm going to work out what the base is. So using Pythagoras' theorem, BC equals the square root of 10 squared minus 8 squared, which, putting that into our calculator, 100 minus 64 is 36. Square rooting that is 6. So that confirms that the area of the triangle is 24, half base times height, perpendicular height. It's a right angle triangle, I can see this. Okay, so that will be 3 times 8, which would be 24. Right, so we're going to have to work with the area of the triangle here. So if I have the perpendicular height, and all of these are equal to the radius, we're going to have to use this fact that we've got the area of the triangle. So for this, I'm now going to create a series of triangles. So these are quite difficult to see, so I'm going to shade this one in, and I'm going to calculate the area of it. So do see that the base is 10 and the perpendicular height is r. So the area of triangle BAD equals half times 10 times r, which equals 5r centimeters squared. That's the area of triangle BAD. Then I'm going to do the same with CAD. So it's this triangle over here. That's 4r centimeters squared. And then area, the final triangle, which is BAC, just 3r centimeters squared. If I add all of those together, I have the full triangle covered. Okay, so that's 5, 6, 7, 8, 9, 10, 11, 12. So 12r is equal to 24. 12r equals 24. That means r equals 2 centimeters. And to calculate the area of the circle, area of circle equals pi r squared, which equals pi times 2 squared, which equals 4 pi. And we wanted it in terms of pi centimeters squared. And that's that. Right, so using algebra to solve this simultaneous equation, so 2 to the power 2x minus 12 times 2 to the power x plus 32 equals 0, and y equals 2 to the power x. So this looks like I'm going to be able to use a substitution here, because this is the same as y. Now, 2 to the power 2x is exactly the same as 2 to the power x squared. So using the power law for our indices in reverse, we can see that we can split that apart. So I can rewrite this equation as y squared minus 12y plus 32 equals 0, making this substitution that y equals 2x, 2 to the power x. So solving this equation, we want, this will factorize y minus 8 and y minus 4 equals 0. That means y equals 4 or y equals 8. But we're not finished that. We've got the values of y, but we now need to substitute in the values of x. So if y equals 4, that means 2 to the power x equals 4. Well, that means x must equal 2, because 2 squared equals 4. And if 2 to the x equals 8, that means x must equal 3. So x equals 2 when y equals 4. X equals 2, y equals 4, and x equals 3 when y equals 8. Right, so the graph below shows an incomplete frequency polygon. The table is an incomplete cumulative frequency table. So they are both based on the same data, looking at the mass of 75 rabbits. So we have a frequency polygon and a cumulative frequency table. So these do not go together. So I need to have another piece of, or another table, which is the frequency table, that I'm going to use to kind of flip between them. So I can get information from the frequency polygon in terms of frequency. I could put that into the frequency table. I could then populate the cumulative frequency table, and I can go vice versa between all of those three things and then complete them. So I need to use the table to complete the frequency polygon. So, right, so first of all, I've got between 0 and 2, I've got a frequency of 3. So that will also be the same for the cumulative frequency. So I'm going to put my frequency over here. Well, the cumulative frequency goes from 3 to 11, so that means the frequency must be 8. So that means between 2 and 4 must be 8. So that will be 3,8 on the frequency polygon. So 3,8 will be plotted. Then the next one is 5,10 on the frequency polygon. I can see that. That's that point here. Okay. So that means the frequency must be 10 between 4 and 6. So I'm going to add that to the 11 to make 21 on the cumulative frequency table. Then looking at the cumulative frequency, I'm going from 21 to 40. How do I go from 21 to 40? I add 19. So that means that must be 6 to 8, which is my 7. So 7 must be 7,19. 7,19. Just make sure that's at 7. Yep, 7,19. Then from 40 to 55 is 15. So that means that 8 to 10, so that's 9. 9,15. 40 to 15. That's at 9. And then from 55 to 66 is 11. So that's the next one along at 11. 11,11. 11,11. That's plotted at 11. Then the next one is at 13,8. So the frequency table here, that's between 12 and 14. It's 8. Add that to 66, so get 74. And then the last one's 1. So between 14 and 16, so that's 15,1. And then all we need to do is join them. Right, so join the first two. Right, it's not working very well. And that's the frequency polygon completed, and my table, my cumulative frequency table completed as well.